So we have an element of the string, and this string has a radius r, or makes a radius r, and in this element two forces, or well, one force is being applied to this arc. So it is a tension towards this direction, a tension towards this direction, which is making an angle theta with the vertical. The radius of the wave is measured according to the horizontal line. In this situation, then, the sum of forces in x is going to be tension times the cosine of theta minus tension times the cosine of theta equals 0, which will only lead us to tension equals tension. The tension of the string is the same. But the sum of forces in y will state 2 times the tension sine of the angle has to be equal to mass times the acceleration. Now, in this case, the acceleration is going to be a centripetal acceleration because it's going towards the center of the circular motion. We can actually rewrite this expression as 2 times tension sine of theta, and this is going to be equal to mass times velocity squared over the radius. Now, since the angle theta is small, then the sine of theta tends to the angle theta, such that we can actually rewrite this as 2t theta is going to be equal to mv squared over radius. V is the velocity of the string. So where we want to obtain the velocity of the string, if we want to get the velocity of the string is going to be equal to 2 times the tension times r times theta over the mass, the square root of that. Or we can actually state that 2 times the radius times theta is going to be the arc per se. So it's going to be tension times the arc over the mass. We can define the linear density we call it mu, we denote it with the letter mu, and it's going to be equal to the mass per unit length. That's for a string. It's like the volumetric density, mass over volume, but in this case is mass over length. So that's the reason why it's a linear density. Such that at the very end, the velocity of the string is going to be equal to the square root of the tension over the linear density. This is then important. This is the velocity of the wave in